So we are going to now discuss the module 3, that is module 3's revision part. Okay, so what do we mean by memory system? Memory system means if you wanted to calculate the processor speed you can, or you can want to say the computer's performance. It depends on two things: the processor speed, how processor fastly can compute, and the second thing, it depends on how fastly the memory, from the memory you can access the data. So ideally memory can take the data from that memory in a single clock cycle, but in the real case it is not as fast as that. So there is memory interface. Memory interface means here the data, in order to, there are like memory interface when there are set of buses which can carry the address, data and control signals to the processor and between the processor and the memory. That is known as memory interface. So memory interface is a set of buses that can carry different signals like data signals, the data's address and all between the processor and the memory. That is the memory interface. So here if you see, you have to learn to draw this diagram here. That is, we have the processor, memory, they shares a common signal, clock signal. Then I told you that an address would be given by the processor, and also if you want to read the data from that address, read data from the memory, the read data what you wanted would be given here. Now write memory, write is another signal that would be given if you wanted to write something. So write enables connection, that is a write, that would be 0 if it read, if you are reading the data, and that would be 1 if in that address you want to write some data. So whatever data you want to write in that address will be given through this write data signal. Locality of reference means there are two things: temporal locality and spatial locality. Temporal locality means when you access one place and that location that has a chance that you can access it again, like in the loop and row. Spatial locality means then if I am accessing an address x, there are a lot of chances that address x plus 1 and x plus 2 can also be accessed soon. That is in the example of array. That is spatial locality. Now cache hit and cache miss means cache hit happens that CPU first checks the cache. Cache is what is small, fast placed, which is placed in the SRM chip itself. Now we have to understand that cache is very fast. So within 1 to 4 cycles you can access from the cache if the data is present in the cache. If the data is not present in the cache, then we have to go and take it from the memory and all, and you have to give the data to the CPU. So what happens is that approximately 100 clock cycles are basically 100 plus clock cycle would be used in that. CPU sitting idle for a lot of time there. It will be CPU stall and idle at most of the time in cache miss case. So here if you see the memory hierarchy, cache is very fast, then you have the main memory, then you have the our virtual memory, that is hard drive and also virtual memory. So if you see, cache is very small, that is why it's megabytes. Main memory DRAM is very moderate capacity it has, so its size would be given in gigabytes. Then you have the virtual memory, which would be size would give in terabytes. Okay, so this virtual memory would create an illusion of having more RAM than what it has. That is why it is called as virtual memory, and RAM is called as a physical memory. Most fast is what? Cache. Up to 1 to 4 clock cycle you are going to get. Now DRAM, if you check, 60 to 100 nanosecond, but if you see the virtual memory, it takes a lot of time to take the data from the virtual memory. Now the memory hierarchy of the computer system, if you consider, you can see that inside the processor chip itself you have the CPU and also the cache. They are sharing a same clock also. Then we have outside that we have the main memory, and after that only you have the hard drive. So you can see hard drive is very last in the hierarchy, right? So whenever you have to talk about memory hierarchy, you have to learn to draw this diagram also. In the memory system performance, AMAT, that is average memory access time. How do we calculate the average memory access time? If you have a hit in the cache case, we are talking about, if you have a hit in the cache, then the time to access the cache into hit rate if you multiply, plus if it is a miss, then you have to access it from where the memory. So miss rate into T of memory you have to do. This you would give us the average memory access time. And miss rate is what? The number of misses divided by the total access. Hit rate is what? The number of hits divided by the total access. Miss rate can be also called as 1 minus hit rate, and hit rate can be 1 minus miss rate. Average memory access time is hit rate into average memory access time is what? Hit rate into the time taken to access the cache. So T of hit into T of cache, plus if it is miss, then we have to access it from the memory. So miss rate, hit rate into accessing from the cache, plus miss rate into, if then we will access from where, we will access from the memory. So that we have to multiply. Okay, so hit rate is what, the number of cache hits divided by the total memory access. If 90% is hit rate, means 9 out of 10 access are served from the cache. So 1 minus hit rate would be the miss rate. Average memory access time would be what, hit rate into the time taken from cache plus miss rate in the time to access from the memory. This is the average memory access time. The summary. Now this was the capacity and speed trade-off in the memory hierarchy. So this is, whenever you have to talk about memory hierarchy, you have to draw this diagram, then you have to draw this diagram also whenever you are talking about memory hierarchy in the computer system. Okay, so here if you see, this is another diagram which includes cache, main memory, virtual memory and all. Here also capacity and speed trade-off is showing. The main memory's capacity and speed trade-off is basically showing. Now I told you miss rate is the number of misses divided by the total number of memory access, and hit rate is the number of hits divided by the number of the total memory access is equal to 1 minus hit rate. This is 1 minus miss rate, like that we can say. Now calculating the cache performance, that is a question. A program has 2000 data access instruction, 1250 are found in the cache and 750 are not. Find the miss rate and hit rate. So here it is said that a program total has 2000 data access, so 1250 are found in the cache. So hit rate would be what, 1250 divided by 2000. That would be the hit rate. And miss rate would be what, which is not found in the cache, that is 750 divided by 2000. So you can get the, if you multiply this with 100, you can get it in the percentage form. If you multiply this division into 100, if you do, you can get it in what form, in the percentage form. Okay, so average memory access time, if you are having like if you have a 3-level hierarchy, okay, if you have a 3-level hierarchy, then how you can calculate the average? 2-level hierarchy is average memory access time, that is included only the cache and the main memory there. But here we are accessing from the cache. If it is not present in the cache, you are going to do what, miss rate of cache. We are not getting it in the cache, so that means we are getting it from the main memory. If it is not present in the main memory, then main memory miss rate would happen, and then where you will get it from, then main memory miss rate, then you are going to get it from the virtual memory. So to time to access, this is 3-level. Otherwise you are talking about memory and cache only, then we are going to talk about this. We talk about in the terms of cache hit rate. In the terms of cache's hit rate and cache's miss rate, if you wanted the average memory access time, then we will use this formula. But in the terms of memory and cache and disk, first you will access from cache, T of cache, plus otherwise miss rate of cache. Miss rate of cache means then from where you are going to access into T of main memory. Okay, T of main memory. If that is also not possible, plus we are going to means that it is the miss rate of the main memory into where then we will access from the virtual memory. That is why this part is there. Here it is 3-level cache, because here we are using the virtual memory also, but here we are dealing with only the cache and the main memory. That is a simplified formula here. Cache and 2-level hierarchy is T of cache plus otherwise miss rate of cache into accessing the main memory. Here T of cache, then miss rate of the cache, that means we are accessing from the main memory, plus if otherwise that is not possible, that happens because we are having miss rate in main memory, then we are going to multiply it with the T of time taken to access from the virtual memory. Understood? Now calculate the average memory access time in 2-level hierarchy. So this is a 2-level hierarchy, so we have to calculate the average access time in this 2-level hierarchy. So how we are going to do that? Okay, so here if you see, the first thing is that average memory access time we have to calculate. So how can we calculate this average memory access time in 2-level hierarchy? So first we are accessing from the cache, so it is 1 plus miss rate of cache, that is 10%, that is 10 divided by 100, 0.1 into, then we are accessing from the main memory, that is 100. okay, into 100 we have to do. So in this way you can calculate the average memory access time for two level hierarchy. Fine. Now let's see how here in this table what cache miss rate is needed to achieve an average memory access time of 1.5 cycle. That means I needed AMAT to be, so 1.5. So what cache miss rate, that x I want to calculate. So let's say the time to access from the cache was actually 1. Okay, that one we have to write. Okay, then miss rate is x, that we have to calculate. X into time to access from the main memory is 100. So that if you do, I need to get 1.5. So how can I get that? So it means 100x is equal to 0.5 now. So x becomes what? 0.5 divided by 100. X becomes 0.5 divided by 100. Okay, so that means that would be x value, 0.5 divided by 100. So that means it is 0.005. Okay, that would be my x value, which is percentage. In percentage, if you want to calculate, multiply it with 100, that is 0.5 in percentage. 0.5 percentage it should be. Okay, that is what it means. This I have already given the answer and in detail previously itself. That is why I am not doing it again and again. This was the same question. That same question, just the detailed explanation of how we are going to do the same question is given here. Now let's understand the core concept of what we are going to understand, the core concept of the cache. Cache, if you see, before understanding how a cache works, you must understand why it exists. Why do we need a cache? So if you see, the CPU is incredibly fast, but main memory is relatively slow. If CPU had to fetch every single piece of data from RAM, it would spend more of its time just waiting. So here if you see, CPU is very fast and accessing from main memory is very slow. So if the CPU has to take every single of data, if it wanted to take it from the main memory, what happens is that it would waste a lot of its time in waiting itself. So a cache is what? A small, extremely fastest memory chip that is placed directly inside or very close to the CPU. You are placing this cache. So it is a cache is very small, but it is very fast. Okay, it is placed directly inside or like in the SRM chip you are placed, or very close to CPU you are basically placing. Okay, so stores, what happens, the first point about cache is that it stores the frequently used data. This cache would act as a buffer. It holds the copies of data and instruction that the CPU is using right now or likely to use in the future. So what cache stores? Cache stores most frequently used data, the copies of data that the CPU may use it right now or likely to use in the future. The capacity C refers to the total number of data the cache can hold. It usually measured in kilobytes or megabytes. Crucially, the cache capacity is always a tiny fraction of the main memory capacity. Capacity C in the cache term is a number of the it is the total amount of data that you can hold it in our cache, usually in megabytes or kilobytes. That would be there. It is a small portion of, or like a part of what? The small part of the main memory's capacity. That is what you have to understand. The main memory's capacity, a small portion is this. Now, subset of the main memory. So next thing we have is a subset of the main memory. Because the cache is basically very small, what happens is that it cannot hold everything, right? So therefore, at any given time, the cache only contains a small subset or slice of what is currently in the main memory. So it's a subset of the main memory. That is what you have to understand. The processor checks cache first. That is, we already know. First the processor would check cache, then miss or cache hit or cache miss, it will check. Right, that means the CPU must go to the slower main memory to get the data if it is a cache miss. However, because of the subset mode, once the CPU fetches it from the memory, the CPU would fetch that data when it is a cache miss. It also brings that copy of the data into the cache, so the next time needs it will be hit. So what happens is that whenever cache miss happens also, the CPU would fetches the data from the main memory then. But that copy also you have to place it in the cache, because next time when you need that, it will be hit, right? Replacement is that if a cache is already full, when a miss occurs, the cache is already full. So some of the things we have to replace, some of the old data we have to replace. So we need some replacement algorithm in order to do that. Fine. So in the cache, the main things you have to understand is that it stores the most frequently used data. It is a subset of the main memory, and the processor would first check cache. Now the capacity C is the amount of data that it can basically hold. Then we talk about what happens when cache hit and cache miss happens. Whenever cache miss happens, that data that we took from the CPU, took from the main memory, that data copy you have to place it